Thousands of years ago, under the vast expanse of the night sky, ancient civilizations gazed upward with nothing but their eyes and an insatiable curiosity. Yet somehow they managed to predict cosmic events that modern science would only confirm centuries later. These weren't just random guesses. They were precise observations, recorded meticulously on clay tablets, stone carvings, and scrolls. Today, we're diving into 23 intriguing clues from ancient astronomical records that eerily foreshadow modern discoveries. From the Babylonians tracking planetary movements to the Mayans mapping eclipses, these celestial breadcrumbs reveal a profound connection between the past and the present. What did they know that we're only beginning to understand? And how did the stars guide humanity long before telescopes even existed? Join us as we unravel these mysteries, bridging the gap between ancient wisdom and cutting-edge science. The night sky has always been more than just a canvas of twinkling lights. It's a timeless map, and its secrets are waiting to be rediscovered. Long before the invention of telescopes or even paper, the Babylonians were already mapping the heavens with astonishing precision. Using nothing more than clay tablets and sharpened reeds, they etched detailed observations of the night sky, creating what we now call the Babylonian Star Diaries. These ancient records weren't just simple notes, they were meticulous logs of celestial activity, tracking the movements of planets, the phases of the moon, and even the rare occurrence of eclipses. What's truly remarkable is how accurate these records were. Modern astronomers, armed with advanced technology, have compared these ancient observations to today's calculations and found them to be almost spot on. It's as if the Babylonians had a cosmic clock ticking away with the same precision we rely on today. But how did they do it? The Babylonians were masterful sky watchers, dedicating themselves to the study of patterns in the heavens. They believed that the gods communicated through celestial events, and by understanding these signs, they could predict both natural phenomena and human affairs. This deep connection between the sky and their culture drove them to create some of the first systematic records of astronomical activity. Their methods were surprisingly sophisticated, using a base 60-number system, which we still use today for measuring time and angles. They could calculate planetary positions with incredible accuracy. These star diaries weren't just historical curiosities, they were the foundation of astronomy as we know it. Fast forward to today, and these ancient records are still making waves in the scientific community. Modern researchers have used the Babylonian Star Diaries to validate historical eclipses, refine our understanding of Earth's rotation, and even study the long-term behavior of celestial bodies. It's a testament to the enduring power of observation and the timeless quest to understand the cosmos. The Babylonians may not have had satellites or computers, but their dedication to recording the sky's movements has left a legacy that continues to inspire and inform. Their work reminds us that the stars have always been a guide, not just for navigation, but for the very evolution of human knowledge. Imagine stumbling upon a corroded bronze artifact in the depths of the Aegean Sea, only to realize it's a 2,000-year-old celestial calculator. That's exactly what happened in 1901, when divers exploring a shipwreck near the Greek island of Antikythera discovered what we now call the Antikythera Mechanism. At first glance, it looked like a lump of metal, but as researchers began to piece it together, they uncovered something extraordinary. An ancient Greek device so advanced it's often referred to as the world's first analog computer. This intricate machine, dating back to between 150 and 100 BCE, wasn't just a decorative artifact. It was a sophisticated tool designed to predict the movements of the stars and planets, as well as eclipses, with remarkable accuracy. The Antikythera Mechanism is a marvel of ancient engineering, consisting of over 30 interlocking bronze gears housed in a wooden case. It's believed to have been operated by turning a hand crank, which set the gears in motion to simulate the movements of celestial bodies. What's truly astonishing is how precise it was. The device could calculate the positions of the Sun, Moon, and 5 known planets at the time: Mercury, Venus, Mars, Jupiter, and Saturn. It even accounted for irregularities in the Moon's orbit, a feature that wouldn't be fully understood again until the 17th century. This wasn't just a tool for curiosity. It was a practical instrument that likely served astronomers, navigators, and even philosophers. But how did the Greeks achieve this level of sophistication without the tools we take for granted today? The answer lies in their deep understanding of mathematics and astronomy. Scholars like Hipparchus, who lived around the same time, had already made groundbreaking discoveries about the motion of celestial bodies. The Antikythera Mechanism seems to be a physical representation of this knowledge, a way to bring the heavens down to earth. It's a testament to the ingenuity of ancient Greek thinkers, who combined their theoretical insights with practical craftsmanship to create something truly ahead of its time. Deciphering the Antikythera Mechanism hasn't been easy. For decades, its corroded remains baffled researchers until modern technology stepped in. Using advanced three-dimensional imaging techniques, scientists have been able to reconstruct its inner workings and decode the inscriptions on its surface. These inscriptions, written in ancient Greek, provide instructions on how to use the device and even include a calendar of upcoming celestial events. It's like finding an ancient user manual for a piece of technology we're only now beginning to fully appreciate. What makes the Antikythera Mechanism so significant isn't just its complexity, but what it tells us about the evolution of human understanding. This device wasn't just a tool for predicting the stars, it was a bridge between the heavens and earth, a way for ancient people to make sense of the cosmos. In many ways, it foreshadowed the computational astronomy we rely on today, reminding us that the quest to understand the universe is as old as humanity itself. The Antikythera Mechanism isn't just a relic of the past, it's a symbol of the timeless drive to explore, to calculate, and to wonder about the mysteries above. While the Babylonians and Greeks were charting the skies in the Old World on the other side of the globe, the Maya were crafting their own celestial legacy. Far from the bustling cities of Mesopotamia and the marble halls of ancient Greece, the Maya built towering observatories in the heart of the jungle, their eyes fixed on the same stars but with a uniquely Mesoamerican perspective. Among their most enduring contributions to astronomy are the Mayan Codices, intricate, hand-painted books that captured the rhythms of the cosmos in vivid detail. The most famous of these, the Dresden Codex, is a treasure trove of astronomical knowledge, offering a glimpse into a civilization that saw the heavens not just as a source of wonder, but as a guide to life itself. The Dresden Codex is more than just a book, it's a masterpiece of ancient science. Created around the 11th or 12th century, it contains detailed tables tracking the movements of Venus, the Sun, and the Moon. These weren't just simple calendars, they were precise tools for predicting celestial events like solar eclipses and planetary alignments. What's astonishing is how accurate these predictions were. Modern astronomers have analyzed the Codex and found that its calculations align closely with today's sophisticated models. The Maya didn't have telescopes or computers, yet they managed to map the cosmos with a level of precision that still leaves us in awe. So, how did they do it? The Maya were meticulous observers, dedicating entire lifetimes to studying the night sky. They believed that the gods communicated through celestial events, and understanding these signs was essential for everything from agriculture to religious ceremonies. Their astronomers, known as Aj-Tizib, or keepers of the books, recorded their findings in the codices using a complex system of glyphs and symbols. These records weren't just scientific, they were deeply spiritual, reflecting a worldview where the cosmos and Earth were intimately connected. One of the most remarkable features of the Dresden Codex is its Venus table. Venus held a special place in Mayan cosmology, often associated with warfare and divine power. The table tracks the planet's 584-day cycle with incredible accuracy, predicting its appearances as both the morning and evening star. This wasn't just an academic exercise, it had real-world implications. The Maya used these predictions to time important events, from battles to rituals, believing that the gods favored actions taken under the right celestial conditions. It's a fascinating blend of science and spirituality, showing how deeply intertwined astronomy was with every aspect of Mayan life. But the Dresden Codex isn't just about Venus. It also contains detailed eclipse tables predicting when the moon would obscure the sun with stunning precision. The Maya understood that eclipses followed a cyclical pattern, and they used this knowledge to create a system for forecasting them. This wasn't just about avoiding panic during an eclipse, it was about maintaining harmony with the cosmos. For the Maya, an eclipse wasn't just an astronomical event. It was a moment of divine intervention, a time when the God's will was made manifest in the sky. What makes the Mayan Codices so extraordinary is not just their scientific accuracy, but what they reveal about the culture that created them. The Maya saw the universe as a living, breathing entity, a vast network of interconnected forces. Their astronomical records weren't just tools for prediction. They were maps of a sacred landscape, guides to navigating both the heavens and the human experience. In a world without modern technology, they achieved a level of understanding that still resonates with us today. The legacy of the Maya reminds us that astronomy is more than just the study of stars and planets. It's a way of understanding our place in the universe. Their codices are more than historical artifacts. They're windows into a worldview that saw the cosmos as a source of both knowledge and meaning. As we continue to explore the mysteries of the night sky, we stand on the shoulders of these ancient astronomers who looked up and saw not just patterns but purpose. Their work challenges us to see the universe not just as a collection of objects but as a story, one that we're still learning to read. Centuries before the Renaissance sparked a renewed interest in the stars. Ancient Chinese astronomers were already mapping the heavens with extraordinary precision. Their star maps, some of the oldest in existence, weren't just artistic renderings, they were detailed celestial atlases, cataloging constellations, tracking comets, and even documenting the sudden appearance of a mysterious guest star. This phenomenon, recorded in 1054 CE, turned out to be one of the most significant astronomical events in history, the supernova that created the Crab Nebula. But how did they achieve such accuracy without the tools we have today? And what can these ancient maps teach us about the cosmos? The Chinese approach to astronomy was both systematic and deeply rooted in their cultural worldview. They believed that the heavens were a mirror of Earth, with celestial events reflecting the will of the gods and influencing human affairs. This belief drove them to observe the sky meticulously, recording every anomaly from the predictable movements of planets to the unpredictable bursts of supernova. Their star maps were more than just charts, they were tools for divination, governance, and even agriculture, helping rulers make decisions based on the perceived harmony between heaven and earth. One of the most striking examples of their observational prowess is the record of the 1054 guest star. This sudden, bright light in the sky was noted by Chinese astronomers who described it as appearing near the constellation Taurus. Modern astronomers have since identified this event as the birth of the Crab Nebula, a remnant of a supernova explosion. The Chinese records are so precise that they've allowed scientists to trace the nebula's evolution over nearly 1,000 years. It's a remarkable example of how ancient observations continue to inform modern science. But the Chinese didn't just record singular events. they created comprehensive star maps that rivaled the accuracy of later European atlases. Using a combination of careful observation and mathematical calculation, they divided the sky into constellations and plotted the positions of stars with remarkable precision. These maps were often inscribed on stone or silk, preserved for future generations to study. What's fascinating is how they managed to achieve this level of detail without telescopes. Instead, they relied on simple tools like armillary spheres and gnomon sundials, combined with an unyielding dedication to recording the heavens. One of the most famous examples of Chinese celestial cartography is the Dunhuang star chart, dating back to the Tang dynasty around 700 CE. This intricate map, painted on paper, depicts over 1,300 stars grouped into constellations, with detailed annotations about their movements. It's not just a snapshot of the sky. It's a dynamic record of celestial activity, capturing the ever-changing dance of stars and planets. The Dunhuang star chart is a testament to the skill and patience of ancient Chinese astronomers who spent lifetimes observing and documenting the cosmos. These ancient maps weren't just historical curiosities, they had practical applications too. The Chinese used them to predict eclipses, track the seasons, and even forecast weather patterns. Their understanding of celestial cycles was so advanced that they could predict solar and lunar eclipses with impressive accuracy, a feat that required both mathematical skill and a deep knowledge of the sky's rhythms. This blend of practicality and precision made their star maps indispensable tools for both astronomers and rulers. What makes these ancient Chinese records so remarkable is their enduring relevance. Modern astronomers have used them to study the long-term behavior of celestial objects, from the Crab Nebula to the movements of comets. These maps provide a unique window into the past, allowing us to see the sky as it appeared thousands of years ago. They remind us that the stars have always been a source of wonder and inspiration, guiding humanity's quest to understand the universe. The legacy of ancient Chinese astronomy is a testament to the power of observation and the human drive to explore the unknown. Their star maps are more than just historical artifacts, they're a bridge between the past and the present, connecting us to a time when the night sky was both a mystery and a map. As we continue to explore the cosmos, we stand on the shoulders of these ancient astronomers who looked up and saw not just stars but stories waiting to be told. Their work challenges us to see the universe not as a collection of random points of light, but as a living, evolving tapestry, one that we're still learning to read. The ancient Egyptians didn't just build monuments to the gods, they constructed them as gateways to the cosmos. From the towering pyramids of Giza to the sprawling temple of Karnak, their architecture wasn't merely impressive, it was a reflection of their profound connection to the heavens. These structures were more than stone and mortar, they were cosmic calendars meticulously aligned with the stars, the sun, and the moon. The Great Pyramid of Giza, for example, is so precisely oriented to true north that its alignment rivals modern engineering. But how did they achieve such accuracy, and what does it reveal about their understanding of the universe? At the heart of Egyptian astronomy was a belief that the sky was a sacred realm, intimately tied to the rhythms of life on Earth. They saw the movement of celestial bodies as a divine language, one that dictated the seasons, the flooding of the Nile, and even the fate of their pharaohs. To harness this cosmic knowledge, they designed their temples and pyramids to act as both observatories and timekeepers. The Great Pyramid's alignment with the North Star, for instance, wasn't just symbolic, it was a practical tool for navigation and timekeeping. The North Star, known to the Egyptians as the imperishable star, served as a fixed point in the sky, guiding their understanding of the heavens and their place within it. But the pyramids were just the beginning. The Temple of Karnak, one of the largest religious complexes ever built, is a masterclass in celestial alignment. Its massive columns and towering obelisks were positioned to capture the sun's rays during key moments of the year, such as the solstices and equinoxes. On the summer solstice, the sun rises directly over the temple's central axis, flooding the inner sanctuaries with light. This wasn't just a breathtaking spectacle, it was a carefully calculated event, designed to mark the turning of the seasons and the eternal cycle of life and death. For the Egyptians, the sun wasn't just a star, it was the embodiment of the god Ra, whose journey across the sky symbolized renewal and rebirth. What's truly remarkable is how these alignments reveal the Egyptians' advanced understanding of astronomy. Without the use of modern tools, they managed to track the sun's path with incredible precision. They understood the concept of the ecliptic, the apparent path of the sun across the sky, and used it to design their temples. The alignment of structures like the Temple of Abu Simbel, where sunlight penetrates the inner sanctuary only twice a year, on the pharaoh's birthday and coronation day, shows just how deeply intertwined their architecture was with celestial events. These weren't just coincidences, they were deliberate acts of cosmic engineering. The Egyptians also paid close attention to the moon and stars, using them to create a calendar that guided their agriculture and religious rituals. The heliacal rising of Sirius, the brightest star in the night sky, was particularly significant. Its appearance just before sunrise marked the beginning of the Nile's annual flood, a life-giving event that sustained their civilization. By aligning their temples to these celestial markers, the Egyptians created a living calendar, one that connected the rhythms of the earth with the movements of the heavens. It was a way of harmonizing their lives with the cosmos, ensuring that every action was in tune with the divine order. These ancient alignments aren't just relics of a bygone era. They're a testament to the ingenuity and vision of the Egyptians. Modern researchers have used these structures to study everything from the Earth's axial tilt to the long-term changes in the positions of stars. The precision of their alignments has even led some to speculate about the possibility of lost astronomical knowledge, secrets that we're only beginning to uncover. Whether or not these theories hold water, one thing is clear. The Egyptians saw the sky not as a distant void, but as a living, breathing presence, one that shaped every aspect of their world. As we stand in awe of these ancient monuments, we're reminded that the quest to understand the cosmos is as old as civilization itself. The Egyptians didn't just build temples and pyramids, they created a dialogue between the earth and the heavens, a conversation that continues to inspire us today. Their work challenges us to look beyond the stars and see the universe not as a collection of distant objects, but as a source of meaning and connection. In their alignments, we find not just the echoes of an ancient civilization, but a timeless reminder of humanity's enduring fascination with the sky. The Zodiac, a word that conjures images of horoscopes and star signs, might seem like a modern fascination, but its roots stretch back thousands of years to the ancient world. Long before it became a cultural touchstone, the zodiac was a groundbreaking tool for mapping the heavens. Civilizations like the Babylonians and Greeks didn't just look up at the stars and see random patterns. They saw a celestial language, a way to organize the chaos of the night sky into something meaningful. At its core, the zodiac is a band of 12 constellations that lie along the ecliptic, the path the sun appears to take across the sky over the course of a year. This wasn't just about storytelling, it was a systematic way to track time, predict seasons, and navigate the world. The Babylonians were among the first to formalize the zodiac, dividing the sky into 12 equal parts, each associated with a constellation. These divisions weren't arbitrary, they were based on meticulous observations of the sun's movement. By tracking the sun's position against the backdrop of stars, the Babylonians could predict the changing seasons, an essential skill for an agricultural society. The Greeks later adopted and expanded upon this system, integrating it into their mythology and philosophy. To them, the zodiac wasn't just a calendar, it was a reflection of the cosmos's order, a way to connect the human experience to the divine. But the zodiac's significance goes far beyond ancient mythology. Even today, modern astronomy relies on the zodiac as a reference point for celestial navigation. While we no longer use it to predict personal fortunes, the constellations of the zodiac remain a crucial framework for understanding the sky. Astronomers use these 12 constellations to map the positions of planets, comets, and other celestial objects. The ecliptic, the sun's apparent path, still serves as a baseline for measuring the movements of bodies within our solar system. In a way, the zodiac is like a celestial roadmap, a tool that has guided humanity's exploration of the cosmos for millennia. What's fascinating is how the zodiac bridges the gap between science and culture. For ancient civilizations, it was both a practical tool and a source of spiritual meaning. The Greeks, for example, saw the zodiac as a reflection of their myths, with each constellation tied to a story of gods and heroes. The constellation Leo, for instance, was said to represent the Nemean lion slain by Hercules, while Scorpio was linked to the scorpion sent by the goddess Artemis to kill Orion. These stories weren't just entertainment, they were a way to make sense of the universe, to find meaning in the stars. Yet the zodiac's cultural impact doesn't end with the ancients. Even in our modern world, it continues to captivate us. While astrology, the belief that celestial movements influence human affairs, is often dismissed as pseudoscience, it's a testament to the enduring power of the zodiac as a symbol. It reminds us that the stars have always been more than just distant lights, they've been a source of wonder, inspiration, and connection. Whether we're gazing at the night sky or reading a horoscope, we're participating in a tradition that stretches back to the earliest astronomers. But the zodiac isn't static. It's a living system that evolves with our understanding of the cosmos. One of the most intriguing aspects of the zodiac is the phenomenon known as precession, a slow wobble in Earth's axis that causes the positions of the stars to shift over time. This means that the constellations we associate with the zodiac today aren't exactly where they were thousands of years ago. For example, the sun's position at the spring equinox, once in Aries, has gradually shifted into Pisces and will eventually move into Aquarius. This slow dance of the stars is a reminder that the cosmos is always in motion, and our understanding of it must evolve as well. The zodiac's journey from ancient Babylon to modern astronomy is a testament to humanity's enduring curiosity about the stars. It's a reminder that the night sky has always been more than just a canvas of light. It's a map, a calendar, and a storybook all rolled into one. The zodiac isn't just a relic of the past, it's a living tradition, one that continues to inspire us to look up and wonder. As we explore the mysteries of the universe, we're following in the footsteps of those who first mapped the stars, finding our own place in the vast, ever-changing tapestry of the cosmos. Rising from the rolling green plains of southern England, Stonehenge stands as one of the most enigmatic monuments of the ancient world. Its towering stone circles, arranged with almost otherworldly precision, have puzzled researchers for centuries. While many theories have been proposed about its purpose, from a burial site to a place of healing, one idea has gained significant traction. Stonehenge was a Neolithic observatory, a colossal tool for tracking the movements of the sun, moon, and stars. The alignment of its massive stones with the solstices and equinoxes suggests that this ancient site was far more than a ceremonial space. It was a window into the cosmos, built by people who saw the sky as both a calendar and a guide. The most striking evidence of Stonehenge's astronomical purpose lies in its alignment with the summer and winter solstices. During the summer solstice, the sun rises directly over the heel stone, a massive upright slab positioned just outside the main circle. This alignment isn't a coincidence, it's a deliberate design, one that would have marked the longest day of the year with breathtaking precision. Similarly, during the winter solstice, the sun sets in perfect alignment with the central trilithon, the iconic three-stone structure at the heart of the monument. These alignments weren't just symbolic, they were practical, serving as a way to mark the changing seasons and predict the cycles of nature. For a society deeply connected to the land, this knowledge would have been invaluable, guiding everything from planting crops to organizing rituals. But Stonehenge's astronomical significance doesn't stop at the solstices. Recent studies have revealed that the monument may have also been used to track lunar cycles and even predict eclipses. One theory suggests that the arrangement of the stones corresponds to the moon's 6-year cycle, a phenomenon known as the lunar standstill. During this cycle, the moon reaches its most extreme positions in the sky, rising and setting at points far beyond its usual path. By marking these positions with specific stones, the builders of Stonehenge could have tracked this cycle with remarkable accuracy. This level of sophistication hints at a deep understanding of celestial mechanics, one that challenges our assumptions about the capabilities of Neolithic societies. The question of how the builders achieved this precision without modern tools is a source of endless fascination. The stones themselves, some weighing up to 25 tons, were transported from quarries miles away, a feat that required incredible engineering skill and coordination. Once in place, they were carefully positioned to align with specific celestial events. The fact that these alignments remain accurate thousands of years later is a testament to the builders' ingenuity and dedication. It's as if they were trying to create a permanent record of the sky's rhythms, a monument that would endure long after they were gone. What's perhaps most intriguing about Stonehenge is what it reveals about humanity's early attempts to understand the cosmos. For the people who built it, the sky wasn't just a source of light and darkness. It was a living, breathing entity, one that influenced every aspect of their lives. By tracking the movements of the sun and moon, they sought to bring order to the chaos of the natural world, to create a sense of predictability in an unpredictable universe. Stonehenge isn't just a collection of stones, it's a testament to the human desire to make sense of the unknown, to find meaning in the patterns of the sky. As we continue to study Stonehenge, we're reminded that the quest to understand the cosmos is as old as humanity itself. This ancient monument, with its precise alignments and mysterious origins, challenges us to see the sky not as a distant void, but as a source of connection and wonder. It's a reminder that the stars have always been more than just points of light. They've been a map, a calendar, and a story, one that we're still learning to read. And as we stand beneath the towering stones of Stonehenge, we're not just looking at an ancient observatory. We're standing in the footsteps of those who first looked up and saw not just the sky, but the infinite possibilities it held. Nestled in the remote cliffs of Mali, the Dogon people have long held a secret that has baffled astronomers and historians alike. For generations, their oral traditions have spoken of a star invisible to the human eye, a companion to Sirius, the brightest star in our night sky. Known as Sirius B, this white dwarf star orbits Sirius in a tight, elliptical path, and its existence wasn't confirmed by modern science until the 19th century. Yet, the Dogon not only knew about Sirius B, they described its orbit, density, and even its 50-year cycle with remarkable precision. How could a people without telescopes or written records possess such detailed knowledge of a star they couldn't see? This cosmic mystery has sparked decades of debate, blending science, anthropology, and a touch of the unknown. The Dogon's understanding of Sirius B is deeply woven into their culture and cosmology. According to their oral traditions, this knowledge was passed down from their ancestors, who claimed it was given to them by beings from the Sirius system. These beings, known as the Nommo, were described as amphibious, fish-like creatures who descended from the sky in a fiery vessel. They are said to have shared not only astronomical knowledge but also teachings about agriculture, spirituality, and the origins of life. For the Dogon, the Nommo are more than myth. They are a bridge between the earthly and the celestial, a reminder of humanity's connection to the stars. What makes the Dogon's knowledge so astonishing is its accuracy. Sirius B, a white dwarf, is incredibly dense and faint, making it nearly impossible to observe without advanced technology. Yet, the Dogon described it as a small, heavy star made of a metal they called sagala, a term that aligns closely with the modern understanding of white dwarfs as dense, metallic remnants of collapsed stars. They also spoke of its 50-year orbital period around Sirius, which matches the calculations of contemporary astronomers. These details aren't just vague references, they're precise descriptions that align with what we now know about Sirius B and its behavior. But how did the Dogon come to know about Sirius B? This question has fueled intense debate among scholars. Some argue that the Dogon's knowledge could have been influenced by contact with Western astronomers in the early 20th century. During this time, French anthropologists, including Marcel Grioul and Germain Dieterlen, spent years living among the Dogon and documenting their traditions. Critics suggest that the Dogon may have absorbed astronomical knowledge from these outsiders, incorporating it into their own mythology. However, others point out that the Dogon's descriptions of Sirius B predate these interactions, raising the possibility that their knowledge has much older roots. Another theory proposes that the Dogon's insights might have been passed down from an earlier, more advanced civilization. Some researchers speculate that ancient cultures, now lost to history, may have possessed sophisticated astronomical knowledge that was later preserved by groups like the Dogon. This idea taps into a broader fascination with the possibility of forgotten civilizations that understood the cosmos in ways we're only beginning to rediscover. While this theory remains speculative, it adds another layer of intrigue to the mystery of the Dogon and their connection to Sirius. Regardless of its origins, the Dogon's knowledge of Sirius B challenges our assumptions about the history of astronomy. It reminds us that the night sky has been a source of wonder and inquiry for cultures around the world, each bringing their own unique perspective to the study of the stars. The Dogon didn't need telescopes or mathematical models to map the heavens. They used observation, storytelling, and a deep reverence for the cosmos to unlock its secrets. Their traditions invite us to consider that there may be more than one way to understand the universe, blending science and spirituality in a way that feels both ancient and profoundly relevant. The story of the Dogon and Sirius is more than just a cosmic mystery. It's a testament to the enduring human desire to explore the unknown. Whether their knowledge came from ancient wisdom, extraterrestrial contact, or a combination of both, it challenges us to rethink what we know about the stars and our place among them. As we continue to study the cosmos, the Dogon remind us that the universe is full of stories waiting to be told, and sometimes the most extraordinary discoveries come from the most unexpected places. Their connection to Sirius B isn't just a puzzle to solve, it's an invitation to look up and wonder, to see the sky not just as a collection of stars, but as a source of endless possibility. While the Western world often credits the Greeks and Babylonians with laying the foundations of astronomy, ancient India was quietly building its own celestial legacy, one that would rival and, in some cases, surpass the achievements of its contemporaries. At the heart of this legacy are the Vedas, a collection of sacred texts dating back over 3,000 years. These texts aren't just spiritual guides, they're treasure troves of astronomical knowledge, filled with detailed descriptions of planetary movements, celestial cycles, and even the concept of time itself. For the ancient Indians, the cosmos wasn't just a backdrop for myths and rituals. It was a living, breathing system, one that they sought to understand with remarkable precision. The Vedas, particularly the Rig Veda, contain some of the earliest recorded observations of the night sky. They describe the sun as the eye of the universe, a source of light and life, and the moon as a celestial traveler moving through phases. But what's truly astonishing is how these texts go beyond simple observations. They introduce the concept of yugas, vast cycles of time that govern the universe's evolution. According to this system, time isn't linear, it's cyclical, with each yuga lasting thousands of years and marking a distinct phase in the cosmic order. This idea, which might seem abstract, reflects a deep understanding of the universe's rhythms, one that predates modern theories of cosmology by millennia. Building on this foundation, Indian astronomers like Aryabhatta took the study of the heavens to new heights. Born in the 5th century CE, Aryabhatta was a pioneer in both mathematics and astronomy. His seminal work, the Aryabhatiya, is a masterpiece of scientific thought, blending complex calculations with innovative theories. Among his many achievements, Aryabhatta accurately calculated the Earth's circumference, proposed that the Earth rotates on its axis, and even described the causes of eclipses. His explanation of lunar eclipses, for example, was remarkably close to the modern understanding, attributing them to the Earth's shadow rather than mythical creatures or divine interventions. This wasn't just academic curiosity, it was a profound shift in how humanity viewed the cosmos. But Aryabhatta wasn't working in isolation. He was part of a vibrant tradition of Indian astronomers who made groundbreaking contributions to the field. Brahmagupta, another luminary of the 7th century, refined Aryabhatta's calculations and introduced new methods for predicting planetary positions. His work on elliptical orbits and gravitational forces, though not fully developed by modern standards, hinted at concepts that would later be formalized by Newton and Kepler. These astronomers didn't just observe the sky, they sought to explain it using mathematics as their guide. What's fascinating is how these ancient insights continue to resonate today. Modern astronomers have used Indian texts to study historical celestial events, such as eclipses and comets, often finding their records to be remarkably accurate. The Indian concept of nakshatras, or lunar mansions, for example, is still used in traditional astrology and has even found applications in modern astronomy for tracking the moon's path. This seamless blend of ancient wisdom and contemporary science highlights the enduring relevance of India's astronomical heritage. Yet, the legacy of ancient Indian astronomy isn't just about equations and observations. It's also about perspective. For the ancient Indians, the cosmos wasn't just a collection of objects to be studied. It was a source of inspiration and meaning. Their understanding of time cycles, planetary movements, and celestial harmony reflects a worldview that saw the universe as interconnected and alive. This holistic approach, blending science and spirituality, offers a reminder that the pursuit of knowledge isn't just about facts, it's about understanding our place in the grand tapestry of existence. As we look back at the contributions of ancient Indian astronomers, we're reminded that the stars have always been more than just distant lights. They've been guides, teachers, and storytellers, shaping humanity's journey through time. The Vedas and the works of Aryabhatta and Brahmagupta aren't just relics of the past, they're living testaments to the power of curiosity and the endless quest to understand the cosmos. Their legacy challenges us to see the universe not as a cold, empty void, but as a dynamic, interconnected whole, one that continues to inspire and humble us with its mysteries. Buried for over 3,000 years beneath the rolling hills of what is now Germany, the Nebra Sky Disc emerged as a startling glimpse into the minds of Bronze Age sky watchers. Unearthed in 1999 by treasure hunters, this bronze artifact, adorned with gold inlays, is more than just an archaeological marvel. It's one of the oldest known depictions of the cosmos. Measuring about 12 inches in diameter, the disc is a stunning visual representation of the heavens, featuring the sun, a crescent moon, and a scattering of stars. But it's not just a pretty picture. The disc also includes two golden arcs on its edges, thought to represent the solstices, the points in the year when the sun reaches its highest and lowest positions in the sky. This combination of artistry and precision makes the Nebra Sky Disc a groundbreaking artifact, offering a window into how ancient people tracked celestial events long before the advent of modern tools. What makes the Nebra Sky Disc so remarkable is its dual purpose. It wasn't just a symbolic representation of the sky, it was a functional tool. The arcs on either side of the disc are believed to mark the angles of the sun's path during the summer and winter solstices, creating a kind of early calendar. By aligning the disc with the horizon, ancient astronomers could use it to predict the changing seasons, a crucial skill for an agricultural society. The inclusion of the Pleiades star cluster, a group of stars visible to the naked eye, further underscores its practical use. In many cultures, the Pleiades were associated with planting and harvesting cycles, suggesting that the disc may have been used to time agricultural activities. This blend of art and science reveals a society deeply attuned to the rhythms of the natural world, one that saw the sky not just as a source of wonder, but as a guide for daily life. The craftsmanship of the Nebra Sky Disc also speaks volumes about the sophistication of Bronze Age Europe. The use of gold inlays to depict celestial bodies shows a level of artistry and metallurgical skill that challenges the stereotype of this era as primitive or unsophisticated. The disc's creators didn't just understand the sky, they had the technical ability to translate that knowledge into a durable, portable object. This suggests that the disc may have been used by a select group of individuals, possibly priests or shamans, who held the responsibility of interpreting celestial signs and guiding their communities. The disc's design, with its clear markers for solstices and constellations, hints at a society that valued both practical knowledge and spiritual connection to the cosmos. But the Nebra Sky Disc isn't just a relic of the past, it's a testament to humanity's enduring fascination with the stars. Modern researchers have used the disc to gain insights into Bronze Age cosmology, revealing a worldview that saw the heavens as a living, interconnected system. The disc's depiction of the sun, moon, and stars isn't just a static image. It's a dynamic representation of celestial cycles, one that reflects the ancient belief in the harmony between the sky and earth. This holistic perspective, blending observation with mythology, offers a reminder that the study of the stars has always been about more than just science. It's been a way to make sense of our place in the universe. The discovery of the Nebra Sky Disc also raises intriguing questions about the exchange of knowledge in ancient Europe. The disc's design shares similarities with artifacts found in other parts of the continent, suggesting that ideas about astronomy and cosmology may have spread through trade or cultural exchange. This challenges the notion that ancient societies were isolated, instead painting a picture of a connected world where knowledge flowed freely across borders. The disc's creators may have been part of a broader network of sky watchers, sharing observations and insights that shaped their understanding of the cosmos. As we study the Nebra Sky Disc today, we're reminded that the night sky has always been a source of inspiration and guidance. This ancient artifact, with its intricate design and practical purpose, challenges us to see the stars not just as distant lights, but as a map that has guided humanity for millennia. It's a testament to the ingenuity and curiosity of our ancestors, who looked up at the same sky we see today and found meaning in its patterns. the Nebra Sky Disc isn't just a piece of history, it's a bridge between the past and the present, connecting us to a time when the cosmos was both a mystery and a guide. As we continue to explore the universe, we stand on the shoulders of those who first mapped the stars, finding our own place in the vast, ever-changing tapestry of the sky. The transition from myth to science in the realm of astronomy didn't happen overnight. It was a journey shaped by some of the greatest minds of ancient Greece. Figures like Thales, Pythagoras, and Aristotle didn't just gaze at the stars. They questioned, theorized, and laid the groundwork for a scientific understanding of the cosmos. These thinkers transformed astronomy from a collection of myths and divine explanations into a discipline rooted in observation and reason. Their ideas, though sometimes speculative, were revolutionary, challenging the way humanity viewed the universe and its place within it. Thales of Miletus, often regarded as the first philosopher in the Western tradition, was among the earliest to approach the cosmos with a scientific mindset. Living in the 6th century BC, Thales proposed that water was the fundamental substance of the universe, a theory that might seem simplistic today but marked a radical departure from mythological explanations. More importantly, he was one of the first to predict a solar eclipse, an event that had previously been attributed to the whims of the gods. Thales didn't rely on divine intervention to explain the heavens. He looked for patterns and natural causes, setting a precedent for future astronomers. Building on Thales' foundation, Pythagoras took the study of the cosmos to a new level. Known primarily for his mathematical contributions, Pythagoras saw numbers as the key to understanding the universe. He proposed that the Earth was a sphere, not because of empirical evidence, but because he believed the sphere to be the most perfect geometric shape. This idea, though initially based on philosophy rather than observation, would later be confirmed by evidence. Pythagoras also suggested that the movements of celestial bodies could be explained through mathematical relationships, a concept that still underpins modern astronomy. His vision of a harmonious, mathematically ordered universe was a profound shift from the chaotic, God-driven cosmos of mythology. Aristotle, perhaps the most influential of the ancient Greek thinkers, brought a more systematic approach to the study of the heavens. In the 4th century BC, he argued that the Earth was the center of the universe, surrounded by concentric spheres that carried the sun, moon, planets, and stars. While his geocentric model would later be disproven, Aristotle's emphasis on observation and logical reasoning was a cornerstone of scientific thought. He also proposed that the stars were fixed in place, unchanging and eternal, a stark contrast to the unpredictable gods of myth. For Aristotle, the cosmos wasn't a realm of capricious deities. It was a system governed by natural laws, one that could be understood through careful study. What's fascinating about these ancient Greek philosophers is how their ideas, though often incomplete or incorrect by modern standards, set the stage for the scientific revolution. They didn't just describe the cosmos, they sought to explain it, using reason and observation to challenge the boundaries of human knowledge. Their work laid the groundwork for later astronomers like Ptolemy and Copernicus, who built upon their theories to create more accurate models of the universe. But the legacy of these thinkers isn't just about their specific ideas, it's about their approach. They taught us to question, to look beyond the surface, and to seek understanding in the patterns of nature. Their shift from myth to science was more than a change in perspective. It was a transformation in how humanity engages with the unknown. As we continue to explore the cosmos today, we're following in their footsteps, driven by the same curiosity and desire to understand the world around us. The stars, once seen as the domain of gods, became a canvas for human inquiry, a testament to the power of thought and the enduring quest for knowledge. High in the Andes Mountains, the Inca Empire flourished as a civilization deeply intertwined with the heavens. For the Inca, the night sky wasn't just a backdrop for myths. It was a practical tool, a guide for agriculture, architecture, and even governance. Their cities, temples, and fortresses were meticulously aligned with celestial events, blending the practical and the spiritual in ways that continue to awe us today. At the heart of this cosmic connection lies Machu Picchu, the iconic lost city of the Incas, where stone structures and terraces seem to reach toward the stars, as if designed to capture the rhythms of the universe. One of the most striking examples of Inca astronomical ingenuity is the Intihuatana stone at Machu Picchu, often referred to as a hitching post of the sun. This carved granite structure served as a solar clock, marking the changing seasons with remarkable precision. During the solstices, the stone casts no shadow at noon, signaling the sun's pause in its journey across the sky. This wasn't just a symbolic gesture, it was a practical way to track time, helping the Inca plan agricultural activities and religious ceremonies. The Intihuatana stone is a testament to their ability to merge art, science, and spirituality into a single, functional object. But Machu Picchu is just one piece of the puzzle. The Inca Empire spanned thousands of miles, and its capital, Cusco, was designed as a reflection of their cosmology. The city's layout was said to mirror the constellation of the llama, a sacred animal in Inca culture. Key landmarks in Cusco aligned with significant celestial events, such as the rising of the Pleiades star cluster, which marked the start of the planting season. This connection between the heavens and the earth was more than just symbolic. It was a way of life, shaping everything from agriculture to architecture. The Inca also developed a highly sophisticated calendar system known as the sect lines. These were not just imaginary lines on a map, they were physical pathways radiating outward from Cusco, connecting temples, shrines, and natural landmarks. Each sect line corresponded to a specific celestial event, creating a network of sacred geography that guided the Incas' understanding of time and space. This system allowed them to track not only the solstices and equinoxes, but also the cycles of the moon and the movements of the planets. It was a calendar, a map, and a spiritual guide all rolled into one. What's truly remarkable about Inca astronomy is how seamlessly it was integrated into their daily lives. Unlike other ancient civilizations, who often reserved celestial knowledge for priests or elites, the Inca made astronomy accessible to everyone. Farmers used the stars to determine when to plant and harvest crops, while architects designed buildings to align with the sun's path. Even their roads, which stretched across the rugged Andes, were built with celestial markers to aid navigation. This democratization of astronomical knowledge reflects a society that saw the cosmos not as a distant mystery, but as a living, breathing presence that influenced every aspect of life. Yet, the Incas' understanding of the stars wasn't just practical, it was deeply spiritual. They believed that the gods resided in the heavens and that celestial events were messages from the divine. Eclipses, comets, and the appearance of new stars were seen as omens, requiring rituals to maintain harmony between the earthly and the celestial. This blend of science and spirituality is a recurring theme in Inca culture, reminding us that for them, the stars were more than just points of light, they were a source of meaning and connection. Today, the legacy of Inca astronomy continues to inspire. Modern researchers have used their alignments to study everything from ancient agricultural practices to the long-term changes in Earth's axial tilt. Their ability to create such precise systems without modern tools is a testament to their ingenuity and dedication. The Inca remind us that the night sky has always been more than just a canvas of stars. It's a map, a calendar, and a storybook, one that we're still learning to read. As we stand among the ruins of Machu Picchu or walk the ancient sect lines of Cusco, we're reminded of a civilization that saw the cosmos not as a distant void, but as a living, interconnected system. Their work challenges us to see the stars not just as objects to be studied, but as a source of inspiration and guidance. The Inca didn't just look up at the sky, they brought it down to earth, weaving it into the very fabric of their lives. And in doing so, they left behind a legacy that continues to illuminate our understanding of the universe. While the Western world often remembers the Renaissance as the golden age of scientific discovery, centuries earlier, in the heart of the Persian Empire, a different kind of revolution was taking place. Persian astronomers, armed with curiosity and an insatiable desire to understand the cosmos, were making groundbreaking strides in astronomy. Figures like Al-Biruni and Omar Khayyam weren't just scholars, they were pioneers who transformed observatories into vibrant centers of learning, where the mysteries of the universe were unraveled one star at a time. Their work didn't just shape the future of astronomy, it laid the foundation for the scientific method itself. Al-Biruni, a polymath of the 11th century, was a master of precision. His meticulous measurements of the Earth's circumference were astonishingly close to modern calculations, achieved using little more than trigonometry and a keen eye for observation. Al-Biruni didn't just rely on theory, he conducted experiments traveling to different regions to measure angles and distances, proving that the Earth was a sphere. His approach was revolutionary, blending mathematics, geography, and astronomy into a cohesive system of thought. But perhaps his most enduring legacy was his star charts, which catalogued the positions of celestial bodies with remarkable accuracy. These charts weren't just tools for navigation, they were windows into the cosmos, revealing patterns and rhythms that had eluded earlier astronomers. Omar Khayyam, best known for his poetry, was also a brilliant astronomer who left an indelible mark on the field. In the 12th century, he led a team of scholars to reform the Persian calendar, creating a system so precise that it rivaled the Gregorian calendar introduced centuries later. Khayyam's calendar, known as the Jalali calendar, was based on the solar year and adjusted for leap years with a level of sophistication that wasn't matched in the West for hundreds of years. His work wasn't just about tracking time, it was about understanding the deeper rhythms of the universe. Khayyam's observatory in Isfahan became a beacon of scientific inquiry, attracting scholars from across the Islamic world and beyond. These Persian observatories weren't just buildings, they were hubs of innovation where scholars from diverse backgrounds gathered to study the heavens. Equipped with advanced instruments like astrolabes and quadrants, these centers of learning pushed the boundaries of what was possible. The astronomers didn't just observe the stars, they debated, calculated, and theorized, creating a vibrant intellectual culture that valued both empirical evidence and creative thinking. This collaborative environment allowed ideas to flow freely, leading to discoveries that would influence astronomy for centuries. What's particularly striking about Persian astronomy is how it bridged the gap between ancient and modern science. While earlier civilizations often relied on mythology to explain celestial phenomena, Persian astronomers sought natural explanations grounded in observation and mathematics. They didn't just see the stars as divine symbols, they saw them as objects of study, governed by laws that could be understood and predicted. This shift from myth to science was a pivotal moment in the history of astronomy, one that set the stage for the scientific revolution in Europe. The legacy of Persian astronomy isn't confined to the past. Modern researchers continue to draw inspiration from their work, using their star charts and mathematical models to study historical celestial events. Their contributions remind us that the pursuit of knowledge is a universal endeavor, one that transcends borders and cultures. The observatories of Al-Biruni and Omar Khayyam weren't just places of learning. They were symbols of humanity's enduring curiosity, a testament to the power of observation and the desire to understand the cosmos. As we look back at the achievements of these ancient Persian astronomers, we're reminded that the stars have always been more than just distant lights. They've been guides, teachers, and storytellers shaping humanity's journey through time. The work of al-Biruni, Omar Khayyam, and their contemporaries challenges us to see the universe not as a cold, empty void, but as a dynamic, interconnected whole, one that continues to inspire and humble us with its mysteries. Their legacy is a reminder that the night sky isn't just a canvas of stars. It's a map, a calendar, and a storybook, one that we're still learning to read. The Star of Bethlehem, a celestial beacon that has captivated imaginations for centuries, mentioned in the Bible as a guiding light for the Magi, this mysterious star has sparked endless debate among astronomers, historians, and theologians alike. Was it a miraculous event, or could it have been a natural phenomenon recorded by ancient sky watchers? Over the years, several theories have emerged, each offering a tantalizing glimpse into what might have lit up the night sky over 2,000 years ago. One of the most compelling explanations points to a rare planetary conjunction. In the years around the traditionally estimated time of Jesus' birth, there were several notable alignments of planets. For instance, in 7 BC, Jupiter and Saturn appeared to merge in the constellation Pisces, creating a brilliant point of light. To the naked eye, this would have looked like a single, unusually bright star. For the Magi, who were likely skilled astrologers, this celestial event could have held profound significance. In ancient astrological traditions, Jupiter symbolized kingship, while Saturn was associated with the Jewish people. The alignment in Pisces, a sign often linked to the Middle East, might have been interpreted as a divine sign pointing to the birth of a new king. Another theory suggests the Star of Bethlehem could have been a comet. Comets, with their long, glowing tails, have long been seen as omens in many cultures. Chinese astronomical records from around 5 BC describe a broom star that appeared in the sky, which some scholars believe could have been Halley's Comet or another bright comet. While comets are typically seen as harbingers of change or disaster, the Magi might have interpreted it as a sign of something extraordinary, a celestial announcement of a momentous event. A third possibility is that the star was a supernova, a massive stellar explosion that briefly outshines an entire galaxy. Supernovae are rare, but when they occur, they can be visible even during the day. Some ancient records, particularly from Chinese astronomers, mention a guest star that appeared around the same time as the traditional date of Jesus' birth. This could have been a supernova, its sudden brilliance and lingering glow making it a natural candidate for the Star of Bethlehem. The idea of a dying star heralding a new beginning adds a poetic layer to this theory, blending science and symbolism in a way that feels almost mythic. But why has this star remained such a mystery? Part of the challenge lies in the scarcity of detailed records from that time. While ancient astronomers in other parts of the world, like China, kept meticulous notes, much of the historical evidence from the Middle East has been lost or fragmented. Additionally, the biblical account itself is sparse on details, leaving room for interpretation and speculation. This lack of concrete evidence has allowed the Star of Bethlehem to become a canvas for both scientific inquiry and spiritual reflection. What's fascinating about these theories is how they reflect the intersection of astronomy and culture. Whether it was a planetary conjunction, a comet, or a supernova, the Star of Bethlehem wasn't just an astronomical event. It was a story, a symbol, and a moment of wonder. For the Magi, it was a call to action, a sign that set them on a journey. For modern astronomers, it's a puzzle, a chance to piece together clues from ancient records and celestial mechanics. And for believers, it remains a testament to the power of faith and the mystery of the divine. The Star of Bethlehem reminds us that the night sky has always been more than just a collection of stars. It's a source of stories, symbols, and questions that transcend time. Whether viewed through the lens of science or spirituality, this ancient phenomenon continues to inspire curiosity and wonder. As we look up at the same sky that guided the Magi, we're reminded that the stars have always been more than distant lights. They've been guides, storytellers, and mirrors of our deepest hopes and questions. And in that shared wonder, we find a connection that spans centuries, linking us to the countless generations who have gazed upward and found meaning in the heavens. Long before GPS or even compasses, the vast Pacific Ocean was a highway for Polynesian navigators who relied on the stars to guide their voyages across thousands of miles of open water. These ancient mariners didn't just see the night sky as a backdrop. It was their map, their compass, and their lifeline. Without written records or modern tools, they developed an extraordinary system of celestial navigation, using the stars to find their way to distant islands with pinpoint accuracy. Their methods, passed down through generations of oral tradition, reveal a profound connection to the cosmos and a mastery of the heavens that still astonishes us today. At the heart of Polynesian navigation was the concept of wayfinding, a technique that relied on observing natural signs, wind, waves, birds, and most importantly, the stars. Polynesian navigators memorized the positions of hundreds of stars, using them as fixed points to determine direction. They divided the sky into star paths or kavanga, each associated with a specific island or destination. By knowing which stars rose and set over a particular island, they could chart a course even in the middle of the open ocean. It was a system that required not just knowledge but intuition, experience, and an intimate relationship with the natural world. One of the most remarkable tools in their arsenal was the star compass, a mental map of the night sky. Unlike a physical compass which points to magnetic north, the star compass was anchored to the rising and setting points of key stars. For example, the star Arcturus, known as Hokulea in Hawaiian, was a crucial marker for voyaging to the Hawaiian Islands. Navigators would align their canoes with these celestial signposts, adjusting their course as the stars moved across the sky. This wasn't just about following a single star, it was about understanding the entire celestial dance, a skill that required years of training and observation. But Polynesian navigation wasn't just about the stars. These skilled mariners also relied on other natural cues, such as the flight patterns of seabirds, the direction of ocean swells, and even the color of the water. They observed how clouds gathered over distant islands, creating a kind of celestial halo that could be seen from miles away. This holistic approach to navigation, blending astronomy with environmental awareness, allowed them to traverse the Pacific with confidence, even in the absence of landmarks. It was a way of seeing the world that connected the heavens and the earth in a seamless web of knowledge. What's truly extraordinary about Polynesian navigation is how it was preserved and passed down. Without written records, this intricate system of wayfinding was transmitted orally through chants, stories, and hands-on training. Navigators, or PWO, would spend years learning from their elders, memorizing star paths, wave patterns, and the subtle signs of the ocean. This apprenticeship wasn't just about memorization. It was about developing a deep, almost spiritual connection to the sea and the sky. The navigator wasn't just a technician. They were a storyteller, a keeper of ancestral wisdom, and a bridge between generations. Today, the legacy of Polynesian navigation is experiencing a revival. In the 1970s, the Hokulea, a traditional Polynesian voyaging canoe, embarked on a journey from Hawaii to Tahiti using only ancient navigational techniques. The voyage, led by master navigator Maupiailug, proved that these methods were not just relics of the past, they were a living, breathing tradition, capable of guiding modern explorers across the ocean. Since then, the Hokulea has become a symbol of cultural pride and a testament to the enduring power of Polynesian knowledge. It's a reminder that the stars, once seen as guides for ancient mariners, still hold lessons for us today. As we reflect on the achievements of Polynesian navigators, we're reminded that the night sky has always been more than just a canvas of stars. For them, it was a map, a teacher, and a source of inspiration. Their ability to navigate vast distances without modern tools challenges us to rethink what we know about human ingenuity and our relationship with the natural world. The stars, once seen as distant and untouchable, become a living guide connecting us to a tradition that spans millennia. In their story, we find not just a method of navigation, but a profound way of seeing the universe, one that invites us to look up and wonder. While most of us are familiar with the constellations shaped by the stars Orion, Ursa Major, and the like, few know that the night sky also holds patterns created by the absence of light. These enigmatic formations, known as dark constellations, are woven into the fabric of the Milky Way itself. For civilizations like the Inca, who saw the cosmos as a living, interconnected system, these shadowy shapes were just as significant as the glittering stars. They weren't just gaps in the sky, they were stories, symbols, and guides deeply embedded in their mythology and daily life. The Inca, masters of celestial observation, recognized several dark constellations within the Milky Way. Unlike traditional constellations, which are formed by connecting stars, dark constellations are defined by the dense clouds of interstellar dust that block the light of stars behind them. To the Inca, these patches of darkness weren't empty, they were rich with meaning. One of the most prominent dark constellations was Yona Fuyu, or Black Cloud, a shape resembling a serpent slithering across the sky. In Inca cosmology, the serpent was a powerful symbol of transformation and the underworld, linking the heavens to the earth and the spiritual realm. Another notable dark constellation was Machakue, depicted as a serpent or snake-like figure. This celestial creature was believed to influence agricultural cycles, its appearance in the night sky signaling the start of planting or harvesting seasons. The Inca saw these dark patterns as part of a larger cosmic order, one that connected the rhythms of nature with the movements of the stars. By observing these constellations, they could align their lives with the cycles of the universe, ensuring harmony between the earthly and the celestial. It was a way of seeing the sky that went beyond the visible, embracing the shadows as much as the light. What's fascinating about dark constellations is how they challenge our modern perspective on astronomy. While we often focus on the stars themselves, the Inca recognized that the spaces between them held just as much significance. This holistic approach reflects a worldview where the cosmos wasn't divided into separate parts, light and dark, visible and invisible, but was seen as a single, interconnected whole. The dark constellations weren't just patterns, they were part of a larger story, one that wove together the physical and the spiritual, the seen and the unseen. The cultural significance of these constellations extended beyond mythology. They were practical tools used to mark time and guide important activities. For example, the appearance of Machakue in the night sky signaled the arrival of the rainy season, a crucial time for planting crops. Similarly, the position of Yona Fuyu was used to predict weather patterns and plan agricultural activities. This blend of practicality and spirituality underscores how deeply astronomy was woven into the fabric of Inca life. The sky wasn't just a backdrop, it was a living map, one that guided everything from farming to religious ceremonies. Today, the concept of dark constellations offers a fresh perspective on how ancient cultures viewed the cosmos. While modern astronomy often focuses on the stars and planets, the Inca remind us that the night sky is full of stories waiting to be told, even in the spaces between the stars. Their recognition of dark constellations challenges us to see the sky not just as a collection of lights, but as a dynamic, interconnected system where even the shadows have meaning. It's a reminder that the universe is full of mysteries, some of which can only be seen when we look beyond the obvious. As we explore these ancient ideas, we're reminded that the night sky has always been more than just a canvas of stars. For the Inca, it was a source of wisdom, a guide, and a reflection of their deepest beliefs. The dark constellations, with their serpentine forms and shadowy beauty, invite us to see the cosmos in a new light, one that embraces the darkness as much as the light. In their story, we find a profound connection to the universe, one that challenges us to look deeper and see more than what's on the surface. The stars may guide us, but sometimes it's the shadows that hold the most meaning. For ancient civilizations, eclipses were more than just celestial events. They were moments of awe, fear, and profound significance. Seen as omens of disaster, divine messages, or cosmic battles between light and darkness, eclipses often sent communities into a frenzy. Yet, amid the fear and superstition, some cultures began to see patterns in the chaos. Through careful observation and meticulous record-keeping, they transformed eclipses from unpredictable terrors into predictable phenomena. Among these pioneers were the Babylonians and the Chinese, whose methods for predicting eclipses were so advanced that they continue to impress modern astronomers. The Babylonians, masters of celestial mathematics, were among the first to crack the code of eclipses. Using a method known as the Saros cycle, they discovered that eclipses repeat in predictable intervals of approximately 18 years, 11 days, and 8 hours. This cycle, based on the alignment of the Sun, Moon, and Earth, allowed them to forecast both solar and lunar eclipses with surprising accuracy. Their records, etched into clay tablets, reveal a society that didn't just fear the heavens, they studied them, turning celestial events into a science. These ancient astronomers didn't have telescopes or computers, but their systematic approach laid the groundwork for the astronomy we rely on today. Equally impressive were the achievements of ancient Chinese astronomers, who saw eclipses as a test of their emperor's mandate from heaven. A poorly predicted eclipse could spell disaster for a ruler, so astronomers were under immense pressure to get it right. Over centuries, they developed intricate methods for tracking the movements of the sun and moon, using tools like armillary spheres and Gnomon sundials to measure angles and positions. Their records, some of the oldest and most detailed in the world, include descriptions of eclipses dating back to over 3,000 years ago. What's remarkable is how closely their predictions align with modern calculations, proving that their methods were rooted in both precision and ingenuity. But how did these ancient astronomers achieve such accuracy without modern technology? The answer lies in their dedication to observation and their ability to recognize patterns. Both the Babylonians and the Chinese kept detailed logs of celestial events, noting the timing, duration, and appearance of eclipses. Over generations, these records allowed them to identify cycles and develop mathematical models that could predict future events. It's a testament to the power of persistence and the human drive to understand the unknown. While their tools were simple, their insights were profound, bridging the gap between myth and science. What's fascinating is how these ancient predictions continue to influence modern astronomy. Researchers today use Babylonian and Chinese records to study long-term changes in Earth's rotation and the Moon's orbit. These historical observations provide a unique window into the past, allowing scientists to track how celestial mechanics have evolved over millennia. In a way, these ancient astronomers are still contributing to our understanding of the cosmos, their work preserved in clay and parchment, echoing across the centuries. The shift from viewing eclipses as omens to predicting them with scientific precision marks a pivotal moment in human history. It's a story of curiosity triumphing over fear, of observation transforming into knowledge. The Babylonians and the Chinese didn't just look at the sky, they engaged with it, finding order in what once seemed chaotic. Their legacy reminds us that the night sky has always been more than just a source of wonder. It's a teacher, a guide, and a challenge to our understanding. As we gaze up during an eclipse today, we're not just witnessing a celestial event, we're participating in a tradition that stretches back thousands of years, connecting us to those who first dared to decode the mysteries of the heavens. Mythology and astronomy have always been deeply intertwined, two threads of the same cosmic tapestry. For ancient cultures, the night sky wasn't just a collection of stars and planets. It was a stage where gods, heroes, and mythical creatures played out epic dramas. These stories weren't just entertainment. They were a way to make sense of the universe, to explain the mysteries of the heavens in a language that resonated with the human experience. By weaving their astronomical knowledge into myths and legends, ancient civilizations created a bridge between the tangible and the divine, turning the cosmos into a living, breathing storybook. Take the Greeks, for example. Their mythology is filled with celestial tales that blend observation with imagination. The constellation Orion, depicted as a mighty hunter, was said to have been placed in the stars by Zeus after his death. Orion's belt, a striking line of 3 bright stars, became a celestial marker, guiding both storytellers and navigators. Similarly, the story of Perseus and Andromeda, immortalized in the stars, wasn't just a tale of heroism. It was a way to explain the positions of constellations and the movements of celestial bodies. These myths transformed the abstract into the relatable, giving meaning to the patterns of the night sky. But it wasn't just the Greeks who saw the stars as a canvas for storytelling. In Norse mythology, the Milky Way was known as the Path of the Gods, a shimmering bridge connecting the mortal world to the divine realm of Asgard. The Vikings believed that the Aurora Borealis, or Northern Lights, were the reflections of the shields and armor of the Valkyries, warrior maidens who escorted fallen heroes to the afterlife. These stories weren't just poetic interpretations of natural phenomena. They were a way to navigate both the physical and spiritual worlds, blending astronomy with a deep sense of wonder and reverence. In Mesoamerica, the Maya saw the cosmos as a reflection of their own struggles and triumphs. Their myth of the hero twins, Hunahpu and Xbalanque, who journeyed through the underworld and defeated the lords of death, was mirrored in the movements of Venus. The planet's cycles of disappearance and reappearance were seen as a celestial reenactment of the twins' epic battle, a reminder of the eternal struggle between light and darkness. For the Maya, these myths weren't just stories, they were a way to understand the rhythms of the universe and their place within it. What's fascinating about these myths is how they served a dual purpose. On one hand, they provided a framework for understanding celestial phenomena. On the other, they offered a sense of connection to the cosmos, a way to see the stars not as distant lights, but as part of a larger narrative. This blend of science and storytelling reflects a worldview where the heavens weren't separate from humanity. They were an extension of it, a source of guidance, inspiration, and meaning. Even today, the legacy of these myths continues to shape our understanding of the stars. The names of constellations, planets, and even space missions often draw from these ancient stories, keeping the connection between mythology and astronomy alive. It's a reminder that the night sky has always been more than just a collection of objects to be studied. It's a source of stories, symbols, and questions that transcend time. Whether we're gazing at Orion's belt or marveling at the Northern Lights, we're participating in a tradition that stretches back thousands of years, one that invites us to see the cosmos not just as a place of discovery, but as a source of wonder and connection. As we explore these ancient myths, we're reminded that the stars have always been more than just points of light. They've been guides, teachers, and storytellers. The stories woven into the night sky by cultures around the world challenge us to see the universe not as a cold, empty void, but as a living, interconnected system full of meaning and mystery. In their myths, we find not just explanations of the heavens, but a reflection of humanity's enduring curiosity and creativity. a reminder that the cosmos is as much about the stories we tell as it is about the stars we see. Long before the era of telescopes and satellites, ancient astronomers were already grappling with the challenge of mapping the vast expanse of the night sky. Among the earliest pioneers in this endeavor were figures like Hipparchus and Ptolemy, whose star catalogues became foundational pillars of astronomy. These catalogues weren't just lists of stars, they were sophisticated attempts to bring order to the chaos of the cosmos, creating a systematic framework that would influence astronomers for centuries. Their work wasn't just about naming stars, it was about understanding the universe in a way that had never been done before. Hipparchus, often hailed as one of the greatest astronomers of antiquity, made his mark in the 2nd century BC with a catalogue that documented the positions and brightness of over 1,000 stars. What set his work apart was its precision. Using simple instruments like the astrolabe and dioptra, he measured the positions of stars with remarkable accuracy, creating a reference point for future generations. Hipparchus didn't just record data. He noticed patterns such as the precession of the equinoxes, a slow wobble in Earth's axis that causes the positions of stars to shift over time. This discovery was groundbreaking, revealing that the heavens weren't static but dynamic, evolving over centuries. His catalogue became a cornerstone of ancient astronomy, setting a standard for observation and recording that others would follow. Building on Hipparchus' foundation, Claudius Ptolemy took star mapping to new heights with his Almagest, written in the 2nd century CE. Ptolemy's catalogue expanded on Hipparchus' work, detailing the positions of over 1,000 stars and introducing a coordinate system to map the sky. His method of celestial mapping, using latitude and longitude-like coordinates, was revolutionary. It allowed astronomers to locate stars with greater accuracy and provided a template for future star charts. The Almagest wasn't just a technical manual, it was a synthesis of Greek astronomical knowledge, blending observation with theory to create a comprehensive guide to the heavens. For over a millennium, it remained the definitive text on astronomy, shaping the way scholars viewed the cosmos. The impact of these ancient catalogues extended far beyond their time. Medieval Islamic astronomers like al-Sufi relied on Ptolemy's work to refine their own star maps, adding new observations and correcting errors. During the Renaissance, European astronomers turned to these catalogues as they rediscovered the works of the ancients, using them as a springboard for their own discoveries. Even as telescopes revolutionized astronomy in the 17th century, the foundational principles laid down by Hipparchus and Ptolemy continued to guide star mapping. Their work bridged the gap between the ancient and modern worlds, proving that the quest to understand the stars is a timeless endeavor. What's truly remarkable about these early star catalogues is how they were created with such limited tools. Hipparchus and Ptolemy didn't have the benefit of advanced technology. They relied on their eyes, simple instruments, and an unwavering dedication to observation. Their catalogues weren't just scientific achievements, they were acts of imagination, attempts to capture the infinite in a finite framework. In their work, we see the origins of modern astronomy, the seeds of a discipline that would grow to encompass everything from the motions of planets to the birth of galaxies. Today, the legacy of these ancient star catalogues lives on in the digital databases and sky maps that guide modern astronomers. Projects like the Gaia mission, which is mapping billions of stars with unprecedented precision, owe a debt to the pioneering efforts of Hipparchus and Ptolemy. Their work reminds us that the night sky has always been a source of wonder and discovery, a canvas on which humanity has sought to make its mark. As we look up at the stars today, we're not just seeing points of light, we're seeing the echoes of ancient astronomers who dared to map the unknown, leaving behind a legacy that continues to illuminate our understanding of the cosmos. In the vast expanse of human history, few threads connect the past and present as seamlessly as the study of the stars. Ancient astronomical records, once etched into clay tablets, carved into stone, or painted on papyrus, have proven to be more than just relics of a bygone era. They are living archives, offering modern researchers a window into the cosmos as it appeared thousands of years ago. These records, meticulously kept by civilizations like the Babylonians, Chinese, and Maya, have become crucial tools for understanding phenomena that still intrigue us today, from supernova to the subtle shifts in planetary orbits. Take, for example, the ancient Chinese records of a guest star that appeared in the night sky in 1054 CE. This celestial event, now identified as the supernova that created the Crab Nebula, was documented with such precision that modern astronomers have used it to study the nebula's evolution over nearly a millennium. The Chinese records not only pinpoint the supernova's location, but also describe its brightness and duration, providing a rare snapshot of a cosmic event that unfolded long before the invention of telescopes. This kind of data is invaluable, allowing scientists to compare ancient observations with modern measurements and gain insights into the life cycles of stars. But it's not just supernova that ancient records illuminate. The Babylonians, with their meticulous star diaries, track the movements of planets like Venus and Mars with astonishing accuracy. These observations, recorded on clay tablets, have been instrumental in refining our understanding of planetary motion. Modern researchers have used these ancient logs to study long-term changes in Earth's rotation and the gravitational interactions within our solar system. It's a remarkable example of how the work of sky watchers from thousands of years ago continues to inform cutting-edge science. What makes these ancient records so powerful is their ability to bridge the gap between human history and cosmic time. By studying them, we're not just learning about the stars, we're uncovering the stories of the people who observed them. The Maya, for instance, used their codices to predict eclipses and track the cycles of Venus, blending astronomy with spirituality in a way that reflects their worldview. Their records remind us that the night sky has always been more than just a scientific curiosity. It's been a source of meaning, inspiration, and connection. Today, these ancient insights are more relevant than ever. As we grapple with questions about the origins of the universe and the forces that shape it, we turn to the past for clues. Ancient records provide a baseline, a way to measure how celestial phenomena have changed over millennia. They help us understand the long-term behavior of stars, the evolution of planetary systems, and even the history of our own planet. In a sense, these records are like time capsules, preserving the observations of those who first dared to map the heavens. Yet, the connection between ancient and modern astronomy goes beyond data. It's about the shared human drive to explore, to understand, and to find meaning in the cosmos. The same curiosity that led the Babylonians to track the stars or the Maya to predict eclipses fuels our own quest to unlock the secrets of the universe. In their work, we see the roots of our own scientific endeavors, a reminder that the stars have always been a guide, a teacher, and a source of wonder. As we continue to explore the mysteries of the cosmos, we stand on the shoulders of those who came before us, their records lighting the way forward. The ancient sky watchers may not have had telescopes or satellites, but their observations were no less profound. They remind us that the night sky is not just a canvas of stars, it's a storybook, one that we're still learning to read. And in their records, we find not just data, but a connection to a shared human legacy, a testament to the enduring power of curiosity and the timeless quest to understand the universe. As we delve deeper into the mysteries of ancient astronomy, one question keeps emerging. How do we translate these millennia-old records into something we can understand today? The answer lies in the power of modern technology. From 3D imaging to advanced computer modeling, cutting-edge tools are breathing new life into ancient texts, artifacts, and star charts, revealing insights that were once thought to be lost to time. These technologies aren't just enhancing our understanding, they're revolutionizing the way we connect with the past, turning faded inscriptions and corroded artifacts into windows into the minds of ancient sky watchers. Take, for example, the Antikythera Mechanism, that intricate Greek device we explored earlier. For decades, its corroded fragments were a puzzle no one could solve. But with the advent of 3D imaging, researchers were able to peer inside its complex gears without ever touching the fragile artifact. Using X-ray tomography, they reconstructed its inner workings layer by layer, revealing a level of sophistication that stunned the scientific community. This wasn't just a one-time breakthrough, it opened the door to studying other ancient devices in ways that were previously impossible, preserving their integrity while uncovering their secrets. Another game-changer has been the use of computer modeling to simulate ancient skies. By inputting data from historical records, researchers can recreate the night sky as it appeared thousands of years ago. This has been particularly useful for validating ancient eclipse predictions or tracking the movements of planets and stars mentioned in texts. For instance, the Mayan Dresden Codex, with its intricate Venus tables, has been cross-referenced with computer models to confirm the accuracy of its calculations. It's like having a time machine for the cosmos, allowing us to witness celestial events through the eyes of those who first recorded them. But technology isn't just about decoding the physical or the numerical, it's also about preserving the cultural. High-resolution scans of ancient manuscripts and star maps, like the Dunhuang star chart, have made it possible to study these fragile documents in minute detail without risking damage. Digital archives now allow researchers from around the world to access and analyze these records, fostering collaboration and new discoveries. It's a way of ensuring that these ancient insights aren't just preserved but shared, creating a global dialogue about humanity's shared astronomical heritage. What's truly exciting is how these technological advancements are democratizing the study of ancient astronomy. No longer confined to a handful of experts with access to rare artifacts, these tools are opening up the field to a broader audience. Online platforms and interactive models let anyone explore the Antikythera Mechanism or trace the paths of ancient constellations. It's a reminder that the stars have always belonged to everyone, and now, more than ever, we can all participate in the journey to uncover their secrets. Yet, with all this progress, there's still so much to discover. New technologies are constantly emerging, from artificial intelligence that can decipher ancient scripts to advanced spectroscopy that analyzes the composition of artifacts without invasive techniques. Each innovation brings us closer to understanding the ingenuity of ancient astronomers, their methods, and their motivations. It's a testament to the enduring power of curiosity, both theirs and ours. As we continue to unlock the secrets of ancient astronomical records, we're reminded that the past and the present are more connected than we might think. The tools we use today are built on the knowledge of those who came before us, just as their discoveries laid the groundwork for our own. In this interplay of ancient wisdom and modern innovation, we find a powerful reminder. The quest to understand the cosmos is timeless, a story that spans millennia and connects us all. And with every new technological breakthrough, we're not just decoding the past, we're writing the next chapter in humanity's journey to the stars. For ancient civilizations, the stars weren't just points of light in the sky, they were the threads that wove together the fabric of their cultures. Astronomy was more than a science, it was a language, a religion, and a philosophy, shaping how people understood their place in the cosmos. From the alignment of temples to the timing of rituals, the heavens influenced every aspect of life, creating a profound connection between the earthly and the celestial. This wasn't just about observing the stars, it was about finding meaning in their movements, a way to navigate both the physical and spiritual worlds. In Mesopotamia, the birthplace of astronomy, the stars were seen as divine messages. The Babylonians believed that the gods communicated through celestial events, using the heavens to reveal their will. Priests known as mashmashu were tasked with interpreting these signs, using their knowledge of the stars to guide everything from agriculture to warfare. A sudden eclipse or the appearance of a comet wasn't just a scientific curiosity, it was a call to action, a sign that the gods were watching and waiting. This deep integration of astronomy into religion created a society where the sky was a living, breathing presence, shaping daily life in ways that were both practical and profound. Similarly, in ancient Egypt, the stars were inseparable from spirituality. The annual flooding of the Nile, which sustained their civilization, was believed to be tied to the rising of Sirius, the brightest star in the night sky. This celestial event, known as the Heliacal Rising, marked the beginning of the Egyptian calendar and was celebrated with grand festivals. The pyramids themselves, those enduring symbols of Egyptian ingenuity, were aligned with the stars to ensure the pharaoh's safe passage to the afterlife. For the Egyptians, the heavens weren't just a map, they were a bridge between the mortal world and the divine, a reminder that life and death were part of a greater cosmic order. In the Americas, the Maya took this connection even further. Their cities were designed as reflections of the cosmos, with temples and pyramids aligned to mirror the movements of celestial bodies. The Maya believed that the gods resided in the stars, and their rituals were timed to coincide with astronomical events like eclipses and planetary alignments. The Dresden Codex, with its intricate Venus tables, wasn't just a scientific document, it was a sacred text, a guide to understanding the will of the gods. For the Maya, astronomy wasn't just a tool for prediction. It was a way of maintaining harmony between the earthly and the celestial, ensuring that their world remained in balance. But it wasn't just in grand temples and cosmic calendars that astronomy left its mark. Even in everyday life, the stars played a vital role. In Polynesia, navigators used the night sky to guide their voyages across the vast Pacific, seeing the stars not just as markers of direction but as ancestors who watched over them. In India, the Vedas describe the cosmos as a living system, with the sun and moon as deities who govern the cycles of life and death. For these cultures, the stars weren't distant and impersonal. They were part of the family, guides and protectors in a world full of mystery. What's striking about these ancient worldviews is how they blend the practical with the spiritual. Astronomy wasn't just about understanding the mechanics of the universe, it was about finding meaning in its patterns. The stars were a source of comfort, a way to make sense of the chaos of life and the inevitability of death. They offered a sense of connection, linking individuals to their communities, their ancestors, and the gods themselves. This holistic approach to the cosmos reflects a world view where everything was interconnected, where the heavens and the earth were part of a single, unified system. As we look back at these ancient cultures, we're reminded that the stars have always been more than just objects of study. They've been mirrors, reflecting our deepest hopes, fears, and questions. The way these civilizations integrated astronomy into their lives challenges us to see the universe not just as a place of discovery, but as a source of meaning and connection. Their stories remind us that the night sky isn't just a scientific frontier. It's a canvas for the human imagination, a place where science and spirituality meet, and where the mysteries of the cosmos continue to inspire us today. The story of ancient astronomy is far from over. As we stand on the cusp of new technological and scientific advancements, the potential for uncovering fresh insights from these millennia-old records is greater than ever. Imagine what we might learn as we continue to decode the secrets hidden in clay tablets, star charts, and ancient observatories. The future of ancient astronomy isn't just about revisiting the past, it's about using that knowledge to illuminate the mysteries of the cosmos in ways we can't yet fully grasp. One of the most exciting possibilities lies in the application of artificial intelligence. AI has the potential to analyze vast amounts of ancient astronomical data far more efficiently than humans ever could. By training algorithms to recognize patterns in star catalogs or decode ancient scripts, we could uncover connections and insights that have eluded scholars for centuries. Imagine an AI uncovering a forgotten Babylonian eclipse prediction or reconstructing a lost Mayan celestial calendar. These tools could breathe new life into ancient records, revealing layers of meaning we've yet to explore. Another frontier is the integration of ancient observations with modern astronomical models. By combining the precise data from today's satellites and telescopes with historical records, we could create a more comprehensive picture of celestial phenomena over time. For example, ancient records of supernovae or comets could help us track the long-term behavior of these cosmic events, offering clues about their origins and evolution. This fusion of old and new could transform our understanding of the universe, showing us how the cosmos has changed over millennia and how it might continue to evolve. The future also holds promise for discovering entirely new records. While many ancient texts and artifacts have been lost to time, there's always the possibility of unearthing something extraordinary. Imagine a new cache of Babylonian Star Diaries or a previously unknown Mayan Codex surfacing in an archaeological dig. These discoveries could fill gaps in our knowledge, offering fresh perspectives on how ancient cultures viewed the heavens. Each new find has the potential to rewrite our understanding of history, revealing how humanity's relationship with the stars has shaped our journey through time. But the future of ancient astronomy isn't just about data and discoveries, it's about connection. As we continue to study these records, we're reminded that the stars have always been a source of wonder and inspiration. The same questions that drove the Babylonians, Maya, and Greeks to map the heavens still drive us today. What is our place in the universe? How did it all begin? What lies beyond the stars? By exploring the wisdom of the past, we're not just uncovering ancient knowledge, we're reigniting a timeless conversation, one that transcends cultures and centuries. As we look ahead, the possibilities are as vast as the cosmos itself. The next breakthrough could come from a dusty manuscript, a cutting-edge algorithm, or a serendipitous discovery in an archaeological dig. Whatever form it takes, one thing is certain: the study of ancient astronomy will continue to inspire and inform, bridging the gap between the past and the future. It's a reminder that the stars have always been more than just distant lights. They've been guides, teachers, and storytellers, inviting us to explore the infinite and find our place in the grand tapestry of existence. From the meticulous star diaries of the Babylonians to the intricate Venus tables of the Maya, the astronomical achievements of ancient civilizations are nothing short of extraordinary. These cultures, separated by continents and centuries, shared a common thread, a deep, unwavering fascination with the cosmos. Their records, etched in stone, painted on parchment, or woven into oral traditions, were more than just observations. They were a testament to humanity's enduring quest to understand the universe. Today, as we uncover these 23 remarkable clues, we're reminded that the stars have always been more than distant lights. They've been guides, storytellers, and mirrors of our collective curiosity. What makes these ancient records so remarkable isn't just their accuracy or complexity, it's the profound connection they reveal between humanity and the cosmos. For the Babylonians, the stars were divine messages. For the Maya, they were sacred maps, and for the Polynesians, they were guiding ancestors. Each culture saw the night sky through a unique lens, yet all of them found meaning in its patterns. These ancient astronomers didn't just observe the heavens, they lived by them, weaving the rhythms of the cosmos into the fabric of their daily lives. Their work reminds us that the stars have always been more than a scientific frontier. They've been a source of inspiration, spirituality, and connection. As we stand on the shoulders of these ancient sky watchers, their legacy continues to shape our understanding of the universe. Modern researchers are using their records to study everything from the evolution of stars to the long-term changes in Earth rotation. The precision of their observations, achieved without telescopes or computers, is a testament to the power of human ingenuity and dedication. These ancient clues aren't just historical footnotes, they're living insights, offering new perspectives on the cosmos and our place within it. But the story of ancient astronomy isn't just about the past, it's about the future. As we explore the mysteries of the universe, we're following in the footsteps of those who first dared to map the stars. Their work challenges us to see the night sky not as a distant void, but as a dynamic, interconnected system, full of stories waiting to be told. Whether we're using cutting-edge technology to decode ancient records or gazing up at the same stars that guided the Babylonians and Maya, we're part of a timeless tradition, a shared journey to understand the cosmos. If this journey through time and space has sparked your curiosity, don't forget to hit the like button and subscribe for more explorations into the mysteries of the universe. We'd love to hear your thoughts in the comments. What ancient astronomical discovery fascinates you the most? Let's keep the conversation going. Until next time, keep looking up, because the stars have always been more than just lights in the sky. They're a map, a storybook, and a reminder of the infinite possibilities that